So I'm going to tell you a bit about Airflow, kind of an introduction. I want to tell you what it does, why you might use it, some things that are good to know before jumping in. A little bit about Clover Health. We're a health insurance company. We use Python for literally everything, from our data operations to our web applications to our data science stack, nothing but Python. We're here in San Francisco, one more stop down BART by Pell Street. And we're hiring engineers and data scientists. We have a booth over in the other room, and you can come talk to me, come talk to a couple of our data scientists who are hanging out there. I'm on the data platform engineering team at Clover. I feel a little bit like a plumber because I just mostly move data from one place to another, like a porter. I need a wheelbarrow. I've been using kind of scientific Python since around 2008 when I got a job at NASA Goddard Space Flight Center and started using Python to make images from satellite data and plots. I go by Jiffy Club on the internet because Matt Davis was taken. So if you're looking for me, don't try Matt Davis. It won't work. So it's kind of the outline here. Give you the very brief history of Airflow, and talk about what it's useful for, give you a brief tour of its user interface, then talk about what it's like to put it in production and deploying it, about how you go about putting together a pipeline in Airflow, and then some useful things you should know. So where did Airflow come from? It came out of Airbnb last year. Built by someone who worked on similar infrastructure at Facebook on their data swarm application. His name's Max. This year, Airflow joined the Apache program in their incubator. So I think we can kind of expect to see Airflow around for a long time if that goes well and if it officially joins Apache. So what do you use Airflow for? So a pretty common thing that people need to do is on some sort of schedule, they want a thing to happen. A common thing is taking some data, working on it, and then putting it back out there in some new and polished form. But it could be anything. Airflow is kind of like the alarm clock in this diagram. It's the thing that says, it is now time to run a task, and sends those things off to do stuff. There are other things that do this. There's another Python-based thing called Luigi, and there are some JVM-based things. Airflow is the only one that I have any experience with, which is why I'm talking about it. So if Airflow is the alarm clock here, the rest of this is you. You're building a pipeline of things you want done. And pipelines in Airflow are a series of tasks connected by dependencies. So you want one task to run before others. And I like to call them pipelines because I think that's a more sensible and intuitive name. But in Airflow world, they're called DAGs, or directed acyclic graphs, because you're not allowed to have cyclical dependencies between tasks, because then your pipelines would never finish. So Airflow is really upfront about that. So one of the nice things about this, though, is if you lay out your pipeline, Airflow can be like, okay, I need to run these things before I can run these other things, but those first two tasks are independent. They can run at the same time. So you get some parallelization if you can lay out your tasks like this. So what can those little tasks do? Anything, really. I'm only being a little facetious because you can run arbitrary Python as tasks, and we all know you can use Python for anything. But there are built-in operators operator is the Airflow term for these individual tasks. So when you want to create a task, you create an instance of something called an operator that has a certain interface. You can make your own. But they come with a bunch of built-in ones. So one for calling Python things, one for shelling out to bash, running SQL things, Hive, there are more. You can make your own. So especially with the easy integration with Python, like sky's the limit. You can really do anything you want. We use it for running SQL things a lot of SQL queries, or shifting data from SFTP to S3. But you can use it for sending email, like running your periodic email sending thing, whatever you need it to do. So I'm going to give you a couple of examples of real pipelines that we have at Clover. This is one entire pipeline. They don't have to be fancy. It can be one task that you want run on a schedule. No problem. You can get a little more fancy. So there's a few things we want done, and then it branches out. And those things at the end can run in parallel. A failure on the left side of this would prevent everything from running downstream of it. But a failure here, a failure on that upper branch doesn't affect the lower branch. That stuff will still finish if it can. So another nice thing about Airflow and having laid out your tasks in these independent forks of a pipeline, or maybe even in different pipelines, is some independence there. Those things run separately, and you can get all the way through one part of your pipeline and get as much done as you can, even if one part of it failed. And then there's this. This is our biggest pipeline. You can't even see it there on the right because there are so many tasks. We're going on like 500 tasks in this, and you can tell that the layout, like the interdependency is pretty complicated. There's another view of it there on the left. You can't tell, but those are arrows on the left, so it's showing dependency.
How long does that take to run?
A few hours.
You ever give it to a fresh entrant and say, debug this?
All the time. The first thing we do to new people is usually make them debug things. It's a little rough. No, it's not bad. We support them. Okay, so Airflow comes with an interface. That's how I got those screenshots I was showing you. This is actually one of the really nice things about it, in addition to the fact that it runs the things you tell it to run. It gives you this nice interface for figuring out what's going on and knowing what's going on at any given time. So the default view is kind of like your pipeline status. So this is a list of not all of our pipelines, but some of our pipelines. The name over on the left, you can turn them on and off. The red blocks in the middle under schedule means that one's running right now. And then the statuses show you how many tasks have completed in the dark green. The light green is how many tasks are running right now. You can see if tasks have failed, the red circles. And then these links on the right are out to different views about that pipeline. So this is one potential view for a pipeline, the Gantt chart. I love this because it lets you see very quickly in what order tasks ran, how long they took. So it's very easy to tell which task is taking a long time here. And across the top there, you can see links over to some of the other views. You can see the graph view. Those were the screenshots I was showing you earlier. The task duration is a historical graph showing you how long individual tasks have taken in the past, which is useful for seeing how long, or like how your tasks are scaling, maybe as you've added data over time. See how your tasks are handling that and scaling up with that. It's really useful if you're like, wow, my pipeline took twice as long last night. Like, what happened? You can go to these views and be like, which task was responsible for that? And sometimes it's just one task that you need to debug and find out what was going on. So thanks to these graphs, pretty quick to find those things. And then you can drill into task details. The bottom things here are actually ways to kind of manually tell Airflow to do things. You can clear out like history about this run, which can sometimes be useful if you want to trigger a rerun. So you make Airflow forget that it ran these things by like clearing downstream tasks, like the task and everything downstream of it. And then it'll be like, oh, I haven't run this yet, and rerun it for you, which is useful sometimes. And then you can under task details, you can see all the configuration for that task. You've defined that in code, but this is the quickest way to go see it most of the time. Rendered lets you see the actual code. Especially, this is nice if it was parameterized SQL or Bash. Like, it will render the actual SQL query that ran, or the actual Bash command that ran. And then that log button, also very useful. We store all of the task logs on S3. So when you click that button, Airflow pulls them from S3 and shows them to you. But again, like when a task fails and you want to know why, you go click that button and look at the logs. Hopefully you've written good logs. But even if you're sending logs out to kind of a traditional logging stack like Elasticsearch and Kibana, this is still a much faster way to find the logs specific to a single task. Really handy. That's it for the tour of the UI. That was very quick. The Airflow documentation has a more complete tour, which you can check out. So what does Airflow actually look like when you put it in production? What are the components of it? What do you need running? The first thing you need is a database, a SQL database. So MySQL or Postgres are good things. This is where Airflow stores all of the information about what things have run in the past. How long did they take? What's running right now? And so on. That kind of fills in all of those views I was just showing you. So like that plot of how long tasks took in the past, is calling out to the database and asking like, okay, give me all of the most recent 50 runs of this pipeline, all of the tasks in it, and how long they took, and then it turns it into a plot. So this needs to be kind of a permanent, stable database backing your thing that you don't want data disappearing from. The next thing is a web server. That's obviously what's showing you all of those things I was just showing you. It's a Flask application, pretty straightforward, but you need to run this on some computer where it can talk to the metadata DB. The scheduler is a Python process that decides what to run when. So pretty much nothing runs unless you have started the scheduler. And it goes kind of crawls the file system and looks for, like it's importing Python files out of a directory you configure, looking for DAGs, loading up all of those DAGs, looking at their configuration, and then figuring out when they need to run, and actually putting tasks out there to run on the queue. So if you have a worker queue, the scheduler is the one kind of putting those things on the queue. Or I'll talk in a second about kind of the other ways the scheduler can run, but the scheduler is what is actually deciding what to run when. So a pretty important thing. And then the final component you need are computers running the things that you want to run, the workers. In kind of the full-fledged distributed computing kind of version of this, the recommended engine is Celery, which has been around in Python for a long time for doing distributed task queues with Python. And so it's kind of yet another component of this. So you have to have a Celery queue, task queue, which is usually RabbitMQ or Redis. So if it's Redis, that's another database you need. If it's RabbitMQ, you have to start RabbitMQ servers on the scheduler and on the individual workers. And then on top of that, you have to start Celery workers. There's an Airflow kind of shortcut for this, through the Airflow CLI to start up the individual workers. They don't necessarily have to be on different computers. These could all be on the same computer, but you have to keep in mind that the workers are going to be doing work. And depending on what that work is, they may have different requirements than the scheduler and the web server. The scheduler and the web server are pretty lightweight processes. They don't do a whole lot of actual computing. But your workers may need to be beefy depending what they're doing. They may only be sending commands out to other database things, and in which case they can be very lightweight as well. It just depends. An alternative is to, instead of using Celery, there are other what are called executors, which are the kind of task, they're kind of the components of Airflow that is actually executing the tasks. And so there are ones to run them locally on the same machine as the scheduler, which can save you the headache of dealing with Celery and distributed computing. It's a little bit simpler, but it also means your scheduler and workers are more tightly coupled. So for example, restarting, if you needed to restart the scheduler, it's also going to kill all of the tasks running on that machine at the same time. So it's a bit simpler operationally, but there are trade-offs there. I'll talk a little bit more about that in the future. But that's kind of the basics of Airflow. You need the metadata to be the server, the scheduler, you need some workers, and if you're using distributed workers, you need some way for jobs to get from the scheduler out to those workers, like Celery. Excuse me. So time for some code. What is it like to actually build a pipeline? It starts with a DAG. So you instantiate something called a DAG. You give it a name, the ID. That needs to be unique among all of your DAGs that Airflow is going to import. You give it a start date. This is, for us, most of the time, when we put something into production, we give it a date of like today or tomorrow so that it starts running as soon as we put it in production. But if you put it in the past, Airflow will backfill all the way back to that start date. So it's going to look at the schedule interval and figure out how many times it should have run going back to that start date and actually run all of those. So if there's something that you want run on a cadence where it's like working on a time interval or something and you wanted that going back to some date, like when you started importing a certain data source, you can do that, and Airflow will start from the beginning and run all the way up through the present. And that schedule interval, here it's a cron expression. There are a couple of simple shortcuts for like daily and hourly, but you can also do kind of a complicated cron expression, and Airflow will figure that out. Question?
So when it's backfilling, will it discriminate on data that existed at that time?
That's up to you. Airflow makes available to you the execution date of, I'll explain the execution date in a little bit, but it makes available to your tasks the date at which it's pretending to run, kind of. And so it's up to your task to take that execution date, figure out when, and figure out what time period it's supposed to be operating on and make use of that. So for example, if you're working on selecting like a time series out of a database, you wouldn't use like datetime.now. You would look at the date Airflow is telling you that it's running for and figure out what data to select based on that. The schedule interval can be anything cron can run, but you don't want to go too fine-grained. Airflow only kicks off tasks every minute or 30 seconds or something, so you kind of, it's not really meant to do like sub-second or second or minute. Going down to largish fractions of an hour, I think, is probably the most recommended level to go with these. You can also put that start date in the future if you didn't want it running, and it would sit there and wait until that time came, and then it would start running. So a couple of useful DAG arguments that I didn't talk about there. Default args, these are not arguments to the DAG itself, they're arguments to the tasks you're going to put in the DAG. And so if you have a bunch of ones that are in common across all of the tasks, it's useful to collect them into this default args dictionary and feed them here to the pipeline, and then the pipeline will make sure that those settings are applied to all of the tasks that you add to it. Max active runs tells Airflow how many runs of the entire pipeline should be running concurrently. So you can imagine if you had a daily task that when you put the start date 30 days in the past, that's 30 days of pipeline that Airflow could start running immediately as soon as you put that in production. You may not want 30 of them hitting your database all at the same time or going out to workers all at the same time. There's a global setting of how many DAGs can run at the same time that you can set for Airflow, but then you can set it independently for individual pipelines. So a lot of Clover's pipelines have this set to 1. Because a lot of our pipelines do destructive things to the databases, and we don't want more than one of them doing that at a time. So that's a way to kind of keep that from happening. And then if there are errors in the pipeline and it takes longer than expected to kind of resolve that and stuff, you don't get the next one kicking off before you've got fixes in place, things like that. And finally, concurrency limits how many tasks within the pipeline can run at the same time. This is especially useful for something like that really complicated pipeline I showed you, where potentially dozens of those tasks can be eligible to be run at the same time. That could like take over our entire worker pool and prevent anything else from running at the same time. So we limit that to a few at a time. We actually don't use it during using this concurrency parameter because I don't think this was an option when we started using Airflow, but it would be a good way to go now. Is there a question?
There are errors that allow you to retrace.
To do retries? Mm-hmm. Yeah. So the question was, if there are errors in a task, can you retry them? And the answer is yep. It's a little bit complicated, and I'll talk more about code deployment later, but you can ship new code to the workers and then say, please run this one again. And if everything is hunky-dory, it'll pick up that new code and run the task with the new code, and then the pipeline can progress. Yeah, question?
Is there a way to put a heuristic to say, oh, if this thing has been running for, let's say, 2 hours and it hasn't finished by then, maybe you should like write a log or something like that?
Yep. So the question was, can you put timeouts on things? You can put timeouts both at the pipeline level and the individual task level. So this is coding up a task, or importing the operators module and making a Python operator. The task ID has to be unique within the pipeline. And you have to pass in the DAG here to the operator so that it gets associated with the right pipeline. And then, depending on the task, you're telling it what to run. So here we're pointing it at a function. If this was a SQL task, we could put a string there that was a SQL, like had SQL commands. We could point it at a file that had SQL commands in it. Both of those work. Same with bash. So the magic happens when you make more tasks. So here we make a second one. It's also Python, pointed at a different function. But then we do second task dot set upstream first task, and now we have dependency. The second task cannot run until first task is completed. Right? And so you can put together as many of these as you want. You can do set upstream, you can do set downstream. But this is how you build up a pipeline with tasks that can run in concurrently or have to run in some dependency order.
Are there alternatives like a DSL for constructing these, or do
You
you have to do it programmatically?
have to do it programmatically. But I will sort of circle back to that. So useful task arguments, retries. If it's safe to retry a task, you can tell it to do that. So we have certain tasks where they'll get blocked by kind of database access issues. And we want to wait 5 seconds and try again. So you can set the retry and the retry, like the wait before a retry. Pool is a way of limiting how many of that task can run at the same time. So pool is an Airflow concept where you say, I'm making a pool with 10 workers in it. And then you assign workers to that pool. And every time a worker runs, it takes a slot out of that pool. So only 10 of them can run at this, up to 10 of them can run at the same time. And so for I was telling you about that concurrency parameter earlier. Pools are actually how we are limiting concurrency right now, is by assigning workers to specific pools that only have so many slots in them, so that they're not taking over the whole suite of workers. Queue is a celery option where you can assign tasks to specific celery queues, where you then start a worker listening on that queue, and that's a way to assign tasks to specific workers. And this could be useful when you have workers that are co-located with data, workers that are really computationally beefy in order to do computational tasks, and other workers that are not as beefy because all they do is send commands onto a database, for example, where you want to differentiate where tasks run. Queues, you can use that. There's the execution timeout to put a time limit on it. Trigger rule is the rule for which the task gets executed. So the default is all upstream tasks were successful, but you can change that to things like all upstream tasks failed, or all upstream tasks are done, which is like they've been run and ended in any state, for example. So you can get creative. You can pass in, so in my examples, these functions, as written, these Python functions would have to take no arguments because they're not going to get called with any arguments. But you can set up a dictionary or list of arguments to pass in there to your functions. There's one I forgot here called context, which is a dictionary that Airflow provides that have a bunch of information about the task and like the running environment. And that's how you would get a hold of something like the execution date, like what date Airflow thinks it's running under. You can set environment variables for bash tasks. You can, Airflow has a system that I'm not going to describe in detail, but doing Jinja templating on your tasks. So like if you have SQL or bash, a way of inserting data into those or parameters into those using Jinja templates. So you can provide variables that will be available inside the Jinja templating. So this gets to the question earlier about building more complicated pipelines. You have to use code to write pipelines, but you can get creative about it because it's Python. So if you have a series of files that you want to parse, for example, you can write a loop and create a task for every one of those files. You may or may not tie them to some upstream task that you want run first. But now you've got however many tasks as you have files, and they can all run in parallel. You can let Airflow schedule those. For building that really giant pipeline that I showed you earlier with 500 things in it, nobody wanted to code up 500 things, least of all me. Most of those tasks are, in fact, all of those tasks are either bash shell files or SQL files. So we developed a system where people can write a YAML file that contains the task dependency and the name of the file that needs to be run as part of the task. And when that DAG gets constructed, it starts from some root directory, crawls all of the subdirectories, finds those YAML files, turns them into Airflow tasks, and connects them up in dependency order. So you can do things like that to get around having to code up individually however many tasks you need. We do the same for parsing files. We have, we crawl like SFTP director file things and like pick out files. And again, there's like we do a lot of YAML configuration stuff where like we put YAML configurations in a directory and those get turned into tasks. Okay, so now for some things that are nice to know about Airflow. One is the executor types. I already talked about this a little bit. Executors are the things in charge of actually running your tasks and keeping track of them. We use the Celery executor, so we run Celery in addition to Airflow, and it has a task queue. Airflow puts tasks on those queues, and then the workers pick them up and then send signals back about being done or heartbeats and so on. And so it's really relying on Celery there for that part of it. The sequential executor is has tasks run in the same process as the scheduler. So you'll run it and the scheduler will actually stop scheduling things because it ran a task and it's waiting for it to finish. That's not very useful in production, but it's useful for debugging. I'll show you. The local executor also runs on the same machine as the scheduler, but it uses multiprocessing, Python's multiprocessing module, to run the tasks in a different process so the scheduler can go on doing its thing. And there, according to blog posts I've read about Airflow at other companies, people are using this local executor in production because they kind of want the simplicity of not having a distributed worker queue. And they've made that work for them. Like I said, there would be some challenges around that in terms of like, that doesn't work for us because we have a lot of long running tasks and we want to be able to do maintenance on individual workers or the scheduler without necessarily shutting down any tasks that are running because it would be expensive to have to start them over. So the distributed model works better for us. But if all of your tasks, like if you don't mind restarting tasks or if you're only running Airflow for part of the day, for example, we run Airflow 24/7, so that also kind of makes it challenging to deploy code. But if there's like part of the day when you're running and part of the day when you can put in new code or something like that, the local executor can be an option. Like people are using that in production. And then I don't know much about the Mesos executor, and we don't use Mesos, but if you already had like a Mesos system and like cluster set up, like there's a community contributed option for running your tasks on that. This is a little tip for local debugging. So with options like Celery or multiprocessing, when you want to set a breakpoint in your code, it's not going to work because the process that you use to start Python is not the same one in which the debugger gets invoked. So the sequential executor is a way around that. You use the sequential executor, and you can import PDB and put a breakpoint in your code, and then use the Airflow CLI, the command line interface to Airflow. The command line interface to Airflow is it has a lot of things, and it can do most of the things the scheduler does. And I haven't gone into any detail about it because you can read about it on their website. But it has web server commands and a scheduler command and a worker command and so on. But my favorite utility is Airflow test, where you give it a DAG name and a task name and an execution date, and it runs that task for you without putting any of the information. Like it doesn't care about upstream tasks, it doesn't care about downstream tasks, it's only going to run that one task. It's not going to put any information in the database, but it'll still print out the logs if that's what you want. And if you use the sequential executor, it'll be in the same process as the one that gets started when you run Airflow test, so set trace will work. So this is really useful for debugging when you're setting these up locally. Another tip for pipeline testing, when you're developing a pipeline locally, so at Clover we all, like everybody who works on the pipelines gets Airflow running locally. They have a Postgres running locally so that they have the metadata DB. To actually develop and test pipelines, they'll want to run them locally. So when I'm working on a pipeline locally and I want to run the entire pipeline, I'll put the start date, some date in the past so that Airflow wants to run it. I'll give it a schedule interval of once so that it only tries to run once. And then I'll run it as far as it gets, check the output, check the logs if there are exceptions, so on, all through the interface. And then when I make changes and want to rerun it, I can shut things down. Now just restarting the scheduler won't do that because the record of the DAG having run is still in the database, and Airflow will see that and not try to rerun anything. But you can go through the UI and delete those records from the database, and then Airflow won't know that it has run it in the past, and it'll try again. But using the once flag is useful because then it doesn't matter how long in the past the start date was. Airflow won't try to do any backfilling. It's only going to run it once. Like, that means once ever. It's handy. This is one thing we have a lot of fun with is airflow time. And this is the execution date I'm talking about. So the execution date is something provided to tasks through Airflow's kind of context thing. And part of that is the execution date, because you want to know at what was the planned date at which this ran. But Airflow doesn't actually tell you the date that the task started. It tells you the date of the when the previous task started. So a task starting at 3 o'clock in the afternoon today will have an execution date of 3 a.m. this morning. So it's like covering that interval. So this is a thing to remember. It's really confusing and bugs us all the time, and something you have to keep in mind if you're making use of the execution date in your pipeline. It's kind of general advice. Make sure that your business logic is separate from building Airflow pipelines. I'm working on a project right now that's going to be an Airflow pipeline, and I haven't even imported Airflow into the project yet. I built a CLI into it so I can run it locally and test it and stuff, because adding Airflow on top of that is a whole other layer of things you want to debug, and you want to know that your business logic is solid before you start trying to integrate that with Airflow, because that's going to be a whole nother layer of things you need to work with. So I recommend being able to run and test code without involving Airflow at all. Deploying new code to workers is challenging because they're long-running Python processes. Both the Celery workers and the scheduler are long-running Python processes. And even if we have cron processes running on those same machines that are doing git pulls every few minutes to retrieve the freshest version of the code, but those won't get imported because Python doesn't import things twice, right? It imports them once, and then they're kind of globally cached. So the next time some code needs that thing, it just comes out of that cache. So you need to restart the processes every so often so that they pick up the new code you're shipping. And we've landed on two things for that. For the scheduler, it has this num runs flag that makes the scheduler abort itself after having done so many cycles of like task kickoffs and DAG imports. I think we probably set this to 1 because we want it to restart like every time it does this so that it's very fast at picking up code changes. This means you have to have something restarting it. We have a little script that's running an infinite bash loop around this, but you could also use something like supervisor to do the same thing. And then on the worker side, if you're using Celery, there's this option celery-d max tasks per child that causes Celery to restart workers after having run so many tasks. And again, we set this to 1 so that every time a worker starts up, it's in a new process and is going to pick up the latest code. Okay, so kind of wrapping up here. So having learned all that, why did we actually choose Airflow? It's written in Python, and that's a big deal for us because we use Python for everything internally, and it came down to, so your only options if you're using Python are pretty much Airflow or Luigi. Airflow's UI is really useful, so we like that. The programmatic pipeline construction is the big one. Luigi's pipeline construction involves subclassing to create tasks, and that's much harder to do kind of in a loop, for example. So Airflow won there. And just the fact that Luigi would be fine here also, like complex pipelines are no problem for Luigi either, but we knew we were going to have complex pipelines, and we had confidence that Airflow could handle them. Okay, so these are some links. The Airflow documentation, Clover's website, and my info here. And that's it. Any questions?
Just one, the tasks are kind of, they're all like independent to each other, so you couldn't pass anything from the output one's off to the other.
Yeah, so the question is about passing things from one task to another. There's something called XCOM, or cross communication. So you can have things passed from one task to another, but they have to be essentially strings, like very simple things, tokens. So you can pass back a file name or something like that. You cannot pass something like a data frame.
Do you do all the, like, has to go through databases or like writing files, then the next pass?
Yep. So you have to put it somewhere. You have to move it to S3. You have to put it in a new table in the database, something like that. Yeah. Here.
How do you deal with different requirements for your tasks or like dependencies? Like
Yeah. So the question was, how do we deal with dependencies? I'm assuming Python dependencies.
or okay, so it's all Python. For example, my tutorials had some stuff that's written in R.
Yeah. You have to have deployment for that. We use Docker things because we have to, because of our hosting provider uses Docker. So we have Docker things that install all of whatever we need. But it's very classic Python pip install -r requirements.txt in a Docker image, and then the processes start up in those Docker images by our host.
Does Airflow route tasks to like workers that have the correct environment, or
You could use the celery queues to do that, but our worker pool is the same, so that it doesn't matter. Yeah.
do you have any single point of failure where you go using a scheduler and using a task queue operation?
Potentially, like if the Redis thing, like if the Redis holding the celery queue failed, like you can't talk to workers anymore. If our hosting provider can be a little interesting, like if they go down, like everything's over. It is pretty fault tolerant in terms of like the scheduler is pretty good. Like we haven't had a lot of, it has some interesting quirks, but like it doesn't totally fail. It can do things like, we've seen things like 2 tasks getting picked up on different workers and like competing with each other sometimes. And we don't know whether that's Airflow or Celery's fault, or both, or some interplay. Yeah.
What's the smallest size task in terms of execution, serial execution time that Airflow seems to make sense for the
It's not the task, it's the scheduling rate. And I would say a few minutes, like less than 5 minutes would be probably not a good idea, and I would recommend even more like 15 or 30.
individual tasks?
No, the scheduling interval. An individual task can be instant, and it's fine.
But what does instant mean? So let's say I've got a parallel computation that's going to be, that I want to set, it's a DAG, they're independent, they're not communicating, and each individual task is like sub-second. Let's say like,
Yeah, that's fine.
that's sub-second tasks are okay.
Yeah, it really, the amount of time a task takes to execute, I don't think has any effect on Airflow at all.
There's gotta be this
Oh yeah,
latency overhead, right?
there's absolutely a delay between when the task finishes and when Airflow picks up that it has finished. But hopefully there's not like if you're trying to do sub-second coordination between tasks and Airflow, Airflow is not the right tool.
Yeah. Like, you talk a bit about this, but do you have issues with workflows getting in the backstage or tasks getting lost?
Yes. Rarely, like we'll have this problem with, we'll have this problem with tasks. So the question was about like, do we ever see things like tasks getting lost or tasks getting into a bad state? We do see things where tasks will be marked failed but appear to be still running. But when we check on a box, they're still running, or the opposite, where like Airflow will think a task is running, but when we go look on the box, there's nothing going on. So there's some like Celery communication miscommunication there. We sometimes see like logs disappear, especially when there are retries. So like the first try's logs will disappear when the second try of the task happens, which is something like I really want to fix that. But there is some interesting stuff that can happen in the back.
Operators aware of the data that they're operating on. So let's say I have a final output table where I'll source from like 5 different parents. And I want to know like the exact change that this column has come from. I have like 5 tasks with small strings.
That's something we're very interested in too. So the question was like, does Airflow help you at all with like lineage of your data? The answer is no. We're very interested in that as well, but it's something we're going to have to tackle ourselves. The dependency graph is there, like the task dependency graph, but beyond that, no help from Airflow. Okay, I think lunch is outside probably.
Yeah, 2 announcements. Lunch is outside.